All right, we're going to work on a few questions here. These are all quadratics, and we're looking at different methods of factoring quadratics. Now we have the perfect squares method, and we have the table method, all right? So these are ones that we want to use when we have three terms. So notice we have 1, 2, 3, 1, 2, 3, and then down here, there's also three terms in each expression, okay? So that's the first thing that we notice. Now, the nice thing is that if you have the hidden 1 in front of the first term here, notice I have the x squared term. All right, here there's no hidden 1. There's a 4 and there's a 9. And then we have a 2 and a negative 1 here. If the 1 is there, we can do the table method. All right, it's very easy. We can also do the perfect squares method if you want to try that, but most of you like the table method instead. So you want two numbers that multiply to get this term here, the 64, right? The positive 64. So the number that does not have an x or an x squared. In this example, it's 36. So two numbers that multiply to get 64, and the same exact two numbers that add up to get the 16 here in the middle. So the term with the x. So if you think about that, well, the two numbers that multiply to get 64 is 8 and 8. And then if we have 8 plus 8, that gives us 16, which allows us to start making our brackets. So x here, x here. We have positive 8 as one of them, so plus 8. And positive 8 as our second one, so plus 8. And we're done. And if you look at this, this is a perfect square because it's x plus 8 and there's two of them, so we can square them. So this actually is a perfect squared, okay? So you could have used the perfect squared method, but the box method works all right. If we try it again for this example, two numbers that multiply to get 36, and the same two numbers that add up to get 14. So can we think of those two numbers here? Let's see. Two numbers, so 36 and 14. So we know 6 times 6 is 36, but 6 plus 6 doesn't give us 14. So we have to try and think of some other numbers. So what are some other factors of 36? Well, I know one of them is 3 times 12. That's 36, but 3 plus 12 does not give me 14. So that doesn't help us out much either, does it? Some other factors of 36. Well, we have 9 times 4, well, that's 36, but 9 plus 4, that doesn't give us 14. All right, so what have we done so far? We've done 6 times 6, 3 times 12, 9 times 4. What are some other factors that give us 36? Well, there's 2 times 18, right? But that doesn't give us 14 either, all right? So in this case, we only have 1 times 36 left, okay? So if this is the case, I'm starting to wonder if this even can be factored. So in this question, it says determine whether the following expressions are perfect squares. So because I tried to do the box method in this one, I don't even know if it's a perfect square yet. So let's figure out if it is a perfect square. All right. So the perfect square, if you remember, is you take the first term and we know that that's squared. And the last term, 36, if I want to square a number, how do I get 36? Well, this would be 6, okay? And if this expression is a perfect square, we should be able to go 2 times by the x times by the 6. That should be equal to this middle number. Now, is 2 times x times 6 14x? No, it's 12x. So this here is not a perfect square, so we cannot factor him. All right, so we have to be careful what the instructions will say, okay? Now, these ones here in question 3a, A, and D, now we have this 4 in front and the 9. And the only way we learn to factor quadratic expressions with a number in front other than 1 is by doing perfect squares. So if we set up our perfect square again, all right, I'm going to leave my middle number here the same. Now, what should I square to get 4x squared? Well, we can square 2x, right? That should give us 4x squared. And what can I square in the back here so I get 1? Well, 1 squared. And as soon as we do this, we can check to see if this is a perfect square. Now, they've asked us to factorize it so we can assume it should be a perfect square, but in order to check, what we can do is, can we get 4x in the middle by going this 2x here times by 1 times by, remember we have to times by a 2 in the middle. It always has to be multiplied by 2 in the middle. So 2 times 2 is 4x times 1. There we go. So this should be a perfect square. So what we do is we take our 2x, we put it here. We take our 1 here and we put it here. We have a subtraction sign, so we have to put a negative there, and this whole thing is squared. So that is a perfect square. So that's how we do the perfect square. All right. Just to make sure we understand, we can try this one here on the side. So let's see. I bring 42x here plus squared and squared. That's a squared here. So what do we square to get 9x squared? Well, if we put a 3x in there, that should give us 9x squared. And what number do we square to get 49? Well, that's simple. That's 7. So now we can set up our perfect squared by taking our 3x and putting it here, taking our 7, put it there. Notice we have a plus sign, so in this case it's going to be plus, and there's our perfect squared. All right, so these ones here we have to use our perfect squared method because we have a 4 out front and a 9. Right here we have a 1 and a 1. Our box method worked fine with question 1, except in question B we had that issue where it was not a perfect square, so we had to give up on him. So this was not factorable here. Okay. Finally, we have some more questions. There's some trick questions here. Whenever we want to factorize, we have to check to see if there is a table method first. So if you notice here, we can take a common 2 off every table. So if I do that, you should get this. Okay, so 2x squared, 2 times 6 is 12x, yeah, and 2 times 9 is 18. Good, so 2 I factored out. Now what I'm going to do is, because inside here I have my 1x squared, I can use the box method. So 2 numbers that multiply to get 9, the same 2 numbers that add up to get 6. So in this case it's 3 and 3, and 3 and 3. So we make our 2 brackets like so. And we have this here. And we put our x here, and one number is positive 3, and then the other number is positive 3. So there we go. So there's actually a perfect squared hidden in here, but you have to take out a common 2 at the very first step here, right? So always look for the table method. All right, so that's a tricky one there. There's a common 2. In this last one, if we look, we don't like it when there's negatives in front of the x squared. All right, so what we need to do is, if you like, you can put your little hidden negative 1x squared there. And we're going to take a common negative 1 out of everything here. So when we take a negative out of an expression, all the signs switch. So this negative 1, this x squared becomes positive. This negative 16x becomes positive 16x. And this negative 64 becomes positive 64. Okay. And now look what we have. We have a positive 1x squared, which is exactly like this one here. Okay. And now we can work on the box method. So what I'll do is I'll bring my negative 1 down out here, and I'll put my 2 brackets, and I'll try my box method. So 2 numbers that multiply to get 64, and 2 numbers that add up to get 16. So what do we have? We have 8, 8, and 8, and 8. 8 times 8, 64. 8 plus 8, 16. Perfect. So we put our x here, our x here. Our first number is positive 8, and our second number actually is the same thing, positive 8. And you can see once again, we have something where it's a perfect square, right? X plus 8 times x plus 8. So if we want to rewrite that as our final step, we have our negative 1 on the outside, and this is x plus 8 squared. Okay, So there we have it. Next, let's look at these. These are straight box methods. Notice we have a 1 here and a 1 here. So you can just go straight into the box method. There's no factoring out anything. So two numbers that multiply to get 20 and two numbers that add up to get -9. So now we have to think about our factors. So I know that 4 plus 5 is 9, but I want it to be negative. So if I put the signs and I make this -4, -5, then that works out there, okay? Now, does -4 times -5 give me +20? It also does. Sweet. So we have our two brackets, x, x, and then we have subtract 4, and on the other one, subtract 5, and we factorized it, all right? And finally, we have our last one. So let's take a look at this. It's another easy box method. So two numbers that multiply to get 33, okay? And the same numbers, two numbers that add up to get are 14 here. So make sure you don't confuse these ones here. We always want the product, meaning the multiplication, being around the number that does not have the x here. It was that here as well, here as well, here as well, right? And here as well. So the product is always the number at the very end. It doesn't have the x squared term or the x, okay? And the sum of them always have to be two of the numbers that have the x term. So we need two numbers that add up to get 14. That's the middle. Here we had -4 plus -5. So the two numbers had to add up to get the -9x. Here it was the 16x. And here was the 6x. So make sure you have those in order or else they will not work. So let's go back to this one. Two numbers that multiply to get 33 and add up to get 14. I know that 3 times 11 is 33 and 3 plus 11 is 14. So I put my brackets here. I have my x, I have my x, and I have my 3 that goes there, and I have my 11 that goes there, like so. All right, and now we have it fully factorized. So there's a whole different variety of questions where the first two here, you had to check if there was a perfect square. Well, it ended up being perfect square here using the box method right away. Here we tried to use the box method and we ran into trouble because we ran out of factors, right? None of them were working. So then I decided to check if it was a perfect square, and it was not. So we had to abandon it. We could not factor. These examples, it was perfect square. In these examples, you had to take out a common factor first. Here it's a -1 and here it's a 2. Then it became a box method. And finally, the last ones was the easiest ones. It was just straight box method. All right. So I hope this helps you when you're looking at these questions. So make sure you practice from the chapter. You need to practice in chapters 19E and chapters 19D. All these questions are in here for you to practice, okay? So try and do that on your own. Make sure you practice on your own.